In this video, I'm going to be discussing integers and order of operations, although I'm guessing it'll probably be a second video when we get to order of operations. So let's see what we can get done here. So first of all, we're going to talk about integers, and we've already discussed natural numbers, 1, 2, 3, 4, and so on, or the whole numbers that also include 0. And so now we're at integers, and now we have the negatives. So we have the positive numbers and negative numbers and 0 in the middle. And the integers are used to label the number line, or what we call the real number line, which looks like this. And it's called the real number line because we can represent any real number on the number line, which includes not only the numbers we've discussed so far, but also rational numbers or fractions, and also irrational numbers, a number like pi, 3.14, which I could put somewhere around here on the number line. All right, so let's talk about a couple of other things related to integers. So first of all, -1 and 1 we would say are opposites, or -3 and 3 are opposites. So they have different signs, basically, or the opposite sign. I also want to discuss inequality symbols. We have the less than symbol, the greater or the less than or equal symbol, the greater symbol, and the greater or equal symbol. And so if I gave you -2 and then 4, and I said put the correct symbol in between, the correct inequality symbol, you could actually put the less than symbol or the less than or equal symbol. I'm going to go ahead and put the less than symbol in here. And we know that on the number line, the smaller number will always be on the left. Certainly -2 is to the left of 4 on the number line. So what if I gave you -3 and -8? Well, let's see. If you were to actually put -8 on the number line, it would be out here somewhere. And so you can see that -8 is smaller, which means -3 is greater than -8. And so we would use the greater than symbol. Although we could also use the greater or equal symbol because -3 is greater or equal to -8. So I just want to make that comment here. The smaller of the two numbers is always to the left on the number line. All right, let's move on to the next slide. So one of the things I want to do before we get into order of operations is I want to practice your integer arithmetic. And so I would encourage you to see how many of these 20 problems, well, try all the 20 problems. Try to do it in 2 or 3 minutes if you can. But in any case, do all the problems and then check your answers. Okay, so on number 1, you have a positive times a positive. So 5 times 6 is 30. When we multiply two numbers having the same signs, we're going to get a positive. Number 2, you have -3 times 8. Now we're multiplying opposites, a negative times a positive, and so you're going to get a negative sign. On number 3, you're multiplying two numbers with the same signs, -4 times -7, so you'll get a positive 28. Number 4, you should get -18 because those are opposites. And number 5, -8 times -9 is 72. Now the good news, if you know the rules for multiplication, the rules are the same for division. So on number 6, we're dividing two numbers that have the same signs. 12 divided by 3, you're going to get 4. On number 7, you're multiplying 36 divided by -4. So we're dividing opposites. We're going to get -9. Number 18, -18 divided by -3 is going to be 6. Number 9, -40 divided by 8 is going to be -5. And number 10, -56 divided by -7 is 8. Let's go ahead and do 11 right now. 0 divided by 8. In fact, 0 divided by any number is 0. Now, if I had said 8 divided by 0, hopefully you remember that we can't divide by 0. We would say it's undefined or not defined. Cannot divide by 0. Number 12. Now we're into addition. So 12 through 15 are addition problems. Of course, if you add 5 and 8, you're going to get 13. On number 13, excuse me, you've got -5 plus -8, and so you're adding two negatives. So basically, the rule for when you add two numbers with the same signs is you add the two numbers, ignoring the signs. So in this case, that's 5 and 8, and that would be 13. And then you use the sign of the two numbers. So -5 plus -8 would be -13. Of course, with adding two positive numbers, we really don't need the rule. Now, one way to reason this out is to think in terms of debt. If you owe 5 to one person and you owe 8 to another person, then you owe a total of 13. All right, so let's look at number 14. Here we're adding 5 and -8. So here we're adding opposites. So the rule is, ignoring the signs, we're going to subtract the two numbers. So it'll be 8 minus 5, which is 3. And we'll use the sign of the bigger number, which is 8. And so that would be -3. Again, if you think in terms of debt, if you have $5 but you owe 8, you're $3 in the hole. Look at number 15 now. -5 plus 8. Well, again, you have opposites, so you're going to do 8 minus 5. You're going to ignore the signs and subtract the two numbers. And again, we get 3. But this time, the 8 is the bigger number, and it's got a positive sign. And so we're going to get +3 for our answer. And again, if you think in terms of debt, if you owe $5 but you have 8, you're 3 in the positive. All right, so that gets us to subtraction. On number 16, we have 7 minus 4, which we know is 3. Now, there's a nice rule when you're subtracting integers. At least this is where we normally start when we first learn about subtracting integers. We can write 7 minus 4 as 7 plus -4. This is called adding the opposite. The minus becomes a plus. The +4 becomes -4. And then we just, once we've changed to an addition problem, we use the rules that we were using before. So on number 17, 4 minus 7 becomes 4 plus -7. So the minus becomes a plus, and the 7 becomes a -7. So we're adding the opposite. All right, so 4 and -7, you should get -3. Again, we have opposite signs, so we do 7 minus 4. Again, we're ignoring the signs. 7 minus 4 is 3, and we'll use the sign of the 7. On number 18, -4 minus 7 becomes -4 plus -7. So here we're adding two negatives, so we're going to add 4 and 7 to get 11, and use the sign of the two numbers. 19 becomes 4 plus +7, and of course that's 11. And number 20 becomes -4 plus +7, and so we're going to subtract 7 minus 4, which is 3, and use the sign of the 7, so our answer is +3. All right, so here's the thing. We're doing integers, or focusing on integers in this section, but in this course, Contemporary Mathematics, integer arithmetic is really not as important because we're not, like in an algebra course where you're constantly working with integers. At the same time, you're going to do it work with them in this section, and you'll see them at times. And so it's good to know them, and if you want to get better, let me just show you what you can do. And the other thing I would mention is you certainly have your calculator to help you if you're not sure when you do a problem, but if you want to get better at working with integers, there's a really easy way to do that. There's some things you can do. So number one, there's a website, it's called thatquiz.org, and you can spend really just about 5 minutes a day on it. Click on the Arithmetic tab and you'll get a picture of what we have down here. And you can see you can control the length, the level. Level 10 is a pretty good level. And notice here I have the addition and subtraction buttons on and negatives. And so you can practice adding and subtracting negative numbers or whatever combination you want. You could even just practice your multiplication facts here. So it's a really nice app for practicing with integers. So 5 minutes a day, and if you want to get better, that'll help you get better. Probably the easiest way to get better at working with integers is when you do a problem, first try it, and then check your answer on a calculator. Eventually, you're going to start getting better with those. And finally, if you really want to work on problem areas, like if you see certain commonly missed problems, put them on 3x5 cards and with the answers on the back, and then have someone quiz you, or you can quiz yourself. And so these are some ways you can improve your integer skills if you would like to. All right, so let's look at another topic. Just real quick, I want to talk about absolute value. Some people, when they discuss how to do integer addition, they use absolute value. And I notice the book, I think most books use absolute value when they describe how to add two numbers. And the reason why, what I was saying is just ignore the signs. Well, absolute value makes things positive, and so that's why they use that. But you will see some problems with absolute value, so I wanted to mention these. So if you have the absolute value of 3, why does that equal 3? Well, because the absolute value of a number is its distance from 0 on a number line. So 3, notice, is 3 units from 0 on the number line. And that's why the absolute value of 3 is 3. The absolute value of negative 2 is 2 because, as you can see, negative 2 is 2 units from 0 on the number line. Since we're talking about distances here, the absolute value of a number is always going to be positive. All right, so I have one last topic I want to cover in this video, and then I think I'll finish up with order of operations in a second video. Whoops, I'm getting ahead of myself here. So I want to talk about exponents. So first of all, if you had 7 to the second power, we know that's 7 times 7, which is 49. The 2 is called the exponent, and the 7 is called the base. And so I also want to mention how we say this. This is 7 to the second power, or we could write it or say it as 7 squared. Let's do one more of these. What if we had 4 to the third power? Well, we would multiply 3 4s, and that would be 64. 4 times 4 is 16. 16 times 4 is 64. So here we have 4 to the third power, or we say it as 4 cubed. Now, if I had 5 to the fourth power, there is no shortcut for that or any other higher power. So it's just with the 2 and the 3 that we have these shortcuts for how to say them. Now, I do want to mention one more thing here. Exponents are a shortcut or a nice, easy way to write repeated multiplication. Instead of writing 7 multiplied 10 times, I could just say 7 to the 10th power, for example. That's what we use exponents for. All right, so now I'm ready for you to practice. So I've got some problems for you to evaluate, and then I would encourage you to watch the video and see how you did. All right, so on number 1, you have 5 squared. That means 5 times 5, which is 25. On number 2, you have 2 cubed, which is 2 times 2 times 2, or 8. Number 3, 12 squared is 144. You should know you're up to your 12s at least, hopefully, in your multiplication table. 3 to the fourth, if you multiply 4 3s, 3 times 3 times 3 times 3, you should get 81. I just want to mention that probably the easiest way to do this is to pair up the 3s. 3 times 3 is 9, so this is really 9 times 9, or 81. Anything to the first power is itself, so 8 to the first power is 8. And then we get to numbers 6 and 7, and they look very similar. How would I say these? -3 squared. Pretty much the same way. Is there a difference in their value? And the answer is yes. So if the negative is out front, then we end up getting a different answer than if the negative is inside with the parentheses. So here's why. So the exponent here is 2, but that 2 only applies to the number or letter that it's next to unless there's parentheses. So in this case, my base is just the 3. And so I'm squaring 3, and then I'm applying the negative. So this really means 3 times 3 with a negative out front. The negative is not part of the base, and so we get -9. Now on number 7 with -3 squared, we're multiplying 2 -3's. And so notice here we're going to get a +9. So you got to be really careful with these two cases because the sign and the parentheses make a difference. All right. And so the moral of the story here is know what your base is because it will make a difference. All right, so I'm going to go ahead and stop this video here, and I'll do another video on order of operations.